Yeah, so today's class will do problems. Okay. Yeah, now please take simple problems will take. So based on what I'm to yes. Now please take. So the concepts today we are going to discuss is about the problematic part on photoelectric effect. Understood? Some problems I'll give. So you just find. There is pen, 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 pen. Somewhere here. Wait. Yeah. Please take. So question, this problems based on photoelectric effect is based on, okay. What is the first one? We discussed, right? Yeah, please take first one. Photon energy. Photon energy. Next. Photon energy. Momentum of photon. Next, what I written? Momentum of photon. Einstein's photoelectric intensity of photons also. Intensity of photons. Next, number of photons. Number of photons. Then Einstein's photoelectric equation. Einstein's photoelectric equation. Next, what else? Kinetic energy of photoelectrons and stopping potential. Today we'll discuss this much. Kinetic energy of photoelectrons and stopping potential and stopping potentials. What potentials? Potential. That's it. Okay. Yeah. Next one. One more thing we'll discuss is de Broglie wavelength. De Broglie wavelength of a charged particles. De Broglie wavelength of a charged particle. Please take. So these many topics we will discuss today. Done now? Yes. Now, okay. Done now? Next. Yeah. Now, one by one we'll discuss. First one is photon energy. You should tell now. I will erase it. Photon energy. So, whenever the light photons falls on the metal surface, okay, whenever the photons falls on the metal surface, how much energy the photons will have, the total energy of the photon is always, it is E is equals to what? H mu, correct, right? Formulas, these are the formulas. E is equals to H mu, which is Hc by lambda. H mu is also called Hc by lambda, correct, right? Now what is H? Where H is Planck's constant, H is equals to Planck's constant, which is 6.625 into 10 to the power of minus 34 joule second. This is the Planck's constant H. Energy E is equals to what? Hc by lambda. Done? Now here you see, if you substitute the energy formula H, its constant, into C, velocity of light, by lambda, how much will get? So this will be approximately when lambda is in angstrom, when lambda is in angstrom, then energy E is approximately equal to H is constant, no, and C is 3 into 10 to the power of 8. So I will write this also. C is equals to 3 into 10 to the power of 8 meter per second. That is the velocity of what? Light. Velocity of light. If you multiply these two, then how much you will get? You will get 1 to, okay, 12400 approximately, divided by lambda is in angstrom. This is the approximate value. So this directly you can use. Understood? Okay. Energy, you no need to calculate everything, each and everything. You no need to put this H value, C value, no. 12400, lambda you keep in angstrom. For example, lambda they given in micrometer. Make it in angstrom. 10 to the power of minus 10 you put. Understood? So that above you can write directly this value. Understood? For example, if they give this, what? The lambda is 900 nanometer. What you will do? To how you can make it angstrom? How you can? 900 nanometer is there. So 900 nanometer you can write in angstrom as 9000 angstrom. Correct now? One more 10 you multiply. 900 into 10 is 9000. If you multiply one more 10, nanometer will become angstrom. Understood? See, you are getting confusion. 900 into 10 to the power of minus 9 meter is this value. Correct, right? Now 10 to the power of minus 10, if you want to make it 10 to the power of minus 10 means, what you can do? You take this value, this 0, one more 0 you add. This you can make one more 1. Minus 9 minus 1 is minus 2. Understood? Multiply 10. So multiply 10. So still if you are getting confusion, you just see. Okay. Now I have some 900. Same thing. 900 nanometer is there. nanometer is there. 900 into 10 to the power of minus 9. 10 to the power of minus 9. Now what you will do? I want to make it to 10 to the power of minus 10. 10 to the power of minus 10, what I should do? I should divide by 10. I should divide by 10. Then this 10 it will go up, it will be 10 to the power of minus 10. Correct, Alva? This 10 to the power of this 10, if it go above, then it is 10 to the power of minus 1. Minus 9 into minus 1 is? Minus 10. Correct, right? I divided by 10. And I also multiply by 10. Multiply and divide by 10. If you are getting confusion, listen. If you multiply 900 into 10 is 9000. Correct, right? Into 10 to the power of minus 9 is there. Here I multiplied, but this 10 is remaining. Now 10 to the power of minus 9, and this 10, if it goes up, it will become 10 to the power of minus 1. Now 10 to the power of minus 9 into 10 to the power of minus 1 is how much? Minus 10. Just easy. This is also difficult, no, for you people. That is what making angst. Understood? You should make the value to angstrom level, then you can directly use it. This is the energy of the photon. Okay? Understood? Please take one problem for this. Take one problem. So this energy, sorry to mention, this energy should be in electron volts. If this energy is in electron volts, not in joules, don't take it in joules. Okay, if it is in electron volts, what you will do? You will multiply it with charge of electron, right? E lambda. After multiplying only. 1 minute. I forgot to mention this. Sorry. You see. Don't take 1 minute. Strict the follow song. This is all difficult. Listen. E is equals to H is how much? 6.625 into 10 to the power of minus 34 joule second. Correct? Understood? 34 into C is 3 into 10 to the power of 8. Lambda you keep as it is. It is, if you want to make lambda you keep as it is. Now what I said is that whatever value, whatever you got now, okay, that 1, 2, you see. Now that is in joules, this is in joules. Now you need to convert into electron volts, which what you will do? The energy, how you can convert into electron volts? Divided by the charge of electron. If you divide by the charge of electron, then the energy will be in electron volts. Now you can say, instead of joules, you can write electron volts, and this lambda will be in angstrom. You make it in angstrom. Okay, then how much you will get? The answer is 6.625. Okay, I will. How much you will get? The answer is. Okay, I said no, it is 12375 divided by lambda in angstrom, electron volts. This is the answer, but approximately this 375 we will make it as 400. So you will get 12400 by lambda in angstrom into electrons. This is the answer. This is in electrons. Joules it will not come. This formula you should use only for electron volts. Joules directly you need to do this. Ordinary formula you need to apply. Okay, please take. Try one problem, then you will understand. No, no. Yes. Let's take one question. Take the question. Find the energy of, the total energy of photoelectrons. Write down. You write down. Find the total energy of photoelectrons. The total energy of photoelectrons from light source. From light source of wavelength 400 nanometer, okay, in electron volts. Rich. Find it fast. What is the answer? Solution. You only do. Energy is equals to how much? 12400 divided by lambda in which? Angstrom. Electron volts. This formula direct use. That true. That next true. Yes. Now, how much you'll get? 12400. Lambda is how much? 400 nanometer is how much angstrom? How to convert it into angstrom? Huh? What is our answer final? Lambda. Yes. 4000 angstrom. Correct, right? Okay. Electron volts. This 0 cancel. This 0 cancel. Now 124 divided by 40. How much answer you tell? That is the final answer. Now, angstrom means it is into 10 to the power of minus 10. Confusion, huh? 4000 into 10 to the power of minus 10. Don't make confusion. 3.1 electron volts. That's it. Sir, where's this 10 to the power of minus 10? Why you didn't take? Because already I did, but lambda should be in electron volts. That's it. Don't take the 10 to the power of minus 10 again. Understood? Because already the formula we applied. So this is the answer. 3.1 electron volts. If you do that calculation, no, Hc by lambda, then you will understand H 10 to the power of minus 34, C 10 to the power of 8, minus 34 plus 8, it will go, some 24 of 26 will come. Again this 10 to the power of minus 10, it will go up. That equalizes. This E value again equalizes. So you will get the answer here. I am telling lambda you take it in angstrom. Okay. How much number will come? 4000 angstrom will come. That angstrom number you don't take. That angstrom, just that value take and divide. That's it. 3.1 electron volts. That's the short trick. Understood or not? Understood. Next question you take. Same type. We'll see. Now you see ordinary method. You see. Draw ordinary method we will do. Not this. In joules we will do. Not in electrons. Find the total energy of the photons from light source of wavelength 400 nanometer in joules you do. Joules. Not in electron volts. Joules. Try this. What is the answer? Please tell. E is equals to Hc by lambda. H is what? 6.625 into 10 to the power of 34. 3 is 3 into 10 to the power of 8. C is 3 into 10 to the power of 8 divided by lambda is how much? 400 into 10 to the power of minus 9 nanometer. No. Now you do. How many joules you will get, you see? Here we are not using electron volt. So I am not multiplying electron volt. One minute. This is not looking good now. I will write 6.625 into 10 to the power minus 34 into C 3 into 10 to the power 8. Tell what is the answer fast. That only you got? Tell properly. So this 34 plus 8 how much? 26. 26 plus 9 minus 26 plus 9 minus 26 plus 9 10 to the power minus 26 plus 9 will come. It will become minus 60 or 17 you will get. Minus 17 you will get. 17. Here the power will come minus 17. Okay. Then again if you do 400 and all you will get something. So what is the answer? Final answer, please tell fast. 30 okay 9375 minus what is 6 into 3? Divided 400 you did. 12375 Ma, this is 6.625. No, that is different. Oh, you people are not doing properly. Try fast. It is 6.625 into 10 to the power of minus 34, 3 into 10 to the power of 8 divided by 400 into 10 to the power of minus 9. How much? 31. This is 31, huh? 6 into 6 point into 10 to the power minus 4 into 3 into 10 to the power of 8. How much you get? You tell. Into 3 into 10 to the power of 8. Okay, 6.625 into 3, how much? 19.875 divided by 4 you do. This is 10 to the power of minus 7 I will take because 2 zeros I will remove. Minus 9 will become minus 7. And it is 10 to the power of minus 26. 4.96875 okay into minus 7 it will go up means it will become plus 7. Plus 7 minus 26 10 to the power of minus 19 joules. This is the correct answer. Okay, it is in joules. This is in electron volts. Different. Now you convert to get the same answer. What you need to do? Divided this with the charge of electron. If you divide this with charge of electron, you will get the same answer. Will you do? Because it is in joules. How you can convert joules to electron volts? See, he is thinking so much. How you can convert joules to electron volts? Think. That's good, no? If you think only, you'll get answer. Okay. How you can convert joules to electron volts? What you need to do? We need to multiply charge of electron or divide charge of divided by charge of electron divided by E. If you want to convert electron volts to joules, you need to multiply charge of electron. See, easy.
6.625 into 10 to the power minus 24 into 3 into 10 to the power 8 is 12375.
No, that is correct. 19.875. How 12375? You will not get. No, 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 this one, that one when you multiply with charge of electron answer, you see you will get the answer. You see, Abba, listen, you see. Now you see solution, energy how much you got in joules? 4.96, right, into 10 to the power of minus 19 joules. If you want to convert into electron volts, what you need to do? Divided by charge of electron volt, charge of electron. What is charge of electron? 1.6 into 10 to the power of minus 19. Multiply. I said divide. How much you will get? You will get the same answer. 3 divided by 1.6. Yeah, that's what. See, instead of doing this much, instead of doing converting into first calculating in joules divided by charge of electron, converting to from joules to electron volt, we converted here. This much if you do, you'll get the same answer. Instead of that, directly apply this formula. That's what I'm telling. Understood? Huh? Instead of doing this much, directly apply a simple formula, then you will get the answer. That's what. Okay? Next. I will erase it clean. You want, huh? Yeah. Next one is energy of the photon. Energy of the photon done, right? Next, mass of the photon and momentum of the photon you need to do. Yes. What is mass of the photon? What is the rest mass of photon? What is the rest mass of photon? Hello. Hello, 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 hello. Hello, hello. Hello, hello. What is the rest mass of photon? A photon is a, what is photon first of all? A light. A light is consists of photons. A photon is a light particle which is having the energy in the form of packets called quanta. Understood? And the energy of the photon is because of the moment of photon, and mass of the photon is depends on the velocity of photon. So if you want to know about the photon, photon is light particle, write down this one. Photon is light particle, or in light there are so many photons will be there. So, and the charge of photon or mass, the energy of photon is because of the velocity of photon. Velocity, due to velocity, sorry, wait. The mass of photon, rest mass of photon, m rest, is equals to 0. Photon's rest mass is 0. Photon restal ide. If it is in rest, its energy is 0. Understood? Understood? When you will get when the mass of the photon increases? When it is in movement. Okay, the mass of the photon is not 0 at its motion. At its motion, when it is in moving condition, it will not have 0 mass. The mass will increase. Okay, as the speed of the photon increases, mass will increase. Understood? Understood? Camera people. Now, what is the energy of the photon? Energy is same h mu. Understood? It's the energy of light. You can write nh mu. N is one photon. Like energy, photon energy is in the form of packets. Einstein says. Even Planck says. That's what quantum. Okay, quantum of packets. You know. Anyway, so what is the mass of photon is 0. Okay, now you know energy h mu is equals to mc square. H mu is equals to mc square. What is mc square means? Mass energy relation by Einstein. Correct, right? Einstein says whenever a body is moving with a maximum velocity, like you take the particles, light particles will move with the speed of light, 3 into 10 to the power of 8 meter per second, then that is mc square. Okay, energy is equals to mass into square of the velocity of light. Mass into square of the velocity of light. That is what Einstein says. This is applicable for all microparticles. Every particle it will applicable actually. Okay, mass into square the velocity of light is what we call energy of the particle. Understood? Now, this is also equal to h mu. H mu means the energy of a photon, and photon is also move with the velocity of light because photon is a light only. Now you see, m is equals to what? H mu by c, which is equals to h. What is frequency means? Frequency always we will measure in hertz, number of cycles per second, right? Okay, what is frequency in terms of velocity and wavelength? Tell. C is equals to frequency into wavelength. So frequency is equals to c divided by lambda. Now mu is equals to c divided by lambda into another c is here. This c, this cancels. It is h divided by lambda. This is the mass of a photon. Mass of the photon which is moving. Okay, it is moving with the speed of light. Rest mass of the photon is 0. When the photon is moving only, it has its mass. Understood? Please take this. We will give one question for this. What is energy of the photon then? You can write here. Energy of the photon E is equals to h mu is equals to mc square. Okay? Correct? Now, h. hc by lambda is equals to E. This is the energy. So what is the momentum of photon? This is the energy. What is the momentum of photon? What is the momentum of photon? Don't know. Movement means what? Photon will move. It has a momentum. Yes. The momentum is represented by P. Correct, right? Mass into velocity. Mass into velocity is momentum. Correct, right? But here I using C because it is faster velocity. Celeritas we call. C means celeritas. That speed is very fast. So it is but you know, E is equals to what? mc square. Now P is equals to mc. Now you can write mc. If you multiply one more c, see m into c is already there. Multiply one more c, it is c square divided by c. So it is E by c. That is moment. Correct? Multiply one more c, it is mc square. And divide. Multiply madre divide madಬೇಕು. That's why it is E by c. Okay? That's the momentum of the photon. You can also write E is also equal to h mu by c or h c by lambda c. C cancel, it is h by lambda. So here also h by lambda, h by lambda common. H c by lambda. M is equals to what? H mu by c square. I missed one c. C square. Oh, keep change it. Wrong it. ಕರೆಕ್ಟಾ? ಇಲ್ಲಿ ನೀವು ಯಾಕೆ ಹೇಳಿಲ್ಲ h mu is equals to mc square? m is equals to what? h mu by c square. Now mu is equals to what? C by lambda. C divided by lambda, again c square will be there. One c cancel. So mass is h c lambda. Don't see, oh, so many problem. This please make it, change it. Somewhere we will not take proper c square or c. That will change everything. Okay.
Yes, sir.
Now take one problem, you know. Right. Yes. Fast. Done now. Yes. Take the one question. The momentum of a photon of wavelength 5000 angstrom is, right? The momentum of a photon of an wavelength. They given the wavelength. They are asking calculate momentum. Given wavelength of photon is 5000 angstrom. 5000 angstrom is, find what is the formula? Do it. Yes. ಎಷ್ಟು ಬಂತು? Do it fast. Fast.
Sir, M ಅಂದ್ರೆ ಏನು sir?
M is mass. Momentum ge mass with some. You don't do take that. Take him simple one. What is the formula is there? I have given now. H by lambda. So momentum is h by lambda. H is what? 6.625 into 10 to the power of minus 34 divided by lambda is 5000 angstrom. 5000 into, what is the answer? Minus 10, if you go up it will come plus 10, 34 minus 24, 5000, okay. 5000 you can take 5. 6.625 divided by 5 into 10 to the power of minus 7 into 10 to the power of minus 34. It will become, up it will go, so 6, so 1 point, how much will come? 1.345 into 10 to the power of minus 27. Okay, change na? What is the momentum unit? Huh? What is the unit of momentum? Mass into velocity, correct, right? Kg meter per second. Okay, done now. Now calculate one more question I will give, please write. Yes. Find in the same question also find the mass of photon. Mass of photon. Do it. Also find the mass of photon. Same question. Find the mass of photon. The mass of photon having a wavelength lambda is equals to 5000 angstrom. Do it.
Sir, same ಬರಲ್ಲ sir. Same ಬರುತ್ತೆ sir answer.
Same ಬರುತ್ತಾ? Hey, what is the answer? What is the formula? Mass is equals to what, amma?
H by C.
Very good. Okay, h by c we got a h by lambda we got. Divided by c you do. What is this? It's easy. 1.345 into 10 to the power of minus 27 divided by
C.
3 into 10 to the power 8. How much will get? You only tell the answer. Fast one. So much is there to discuss. 0. 0.448 into 90 na 8 ಮೇಲೆ ಹೋದ್ರೆ okay minus 90. That is the kg. See, what is the mass of photon?
kg mass.
So that means 4.4 into 10 to the power of minus 20 kg, where photon is very, very small. Even if rare. Understood? That's why light is going very fast. Okay. Photons will come like anything, very fast, small value, see. Next, number of photons emitted. Take the heading. Number of photons emitted. Number of photons emitted. Number of photons emitted. What's the number of photons emitted? It is, see, what is the energy of each photon? What is the energy of each photon? E. E, right? E is equals to h into mu. Correct? Now, what is power means? Power means energy divided by time. Energy, time should be 1 second. Energy by time is, or energy is also called work done. Work done per second, t is equals to 1 second is power. How much work it will do in 1 second is what we call power. Okay, now this power is equal to n times the total energy per second. If there is one photon, 1 e. If there are n number of photons, n e. That's why number of photons is power divided by energy. ಅರ್ಥ ಆಯ್ತಾ? Total energy, energy is each photon energy, E. Okay, and power is n into E. If there are n number of photons will come. This is what we call power of photon power. P is what we call photon power. Or pressure also. Pressure is different. Power, Ne. So number of photons is power divided by E. Understood? Next, intensity of emitted photons. Intensity of emitted photons. Energy intensity means how much energy crossing per unit area. How much energy crossing per? We will also call the energy crossing per unit area. Light and photon energy. Energy crossing per unit area. Unit area. This is called photon energy. Photon energy flux. Energy flux or intensity of photons. Energy flux also will call. Understood? Understood or not? Shall I need to write properly? Board is different. Now intensity of emitted photons, I is always what it I is intensity of energy what is? The number of photons emitted per unit area, not number of photons actually, the energy of photons, how much energy per second per unit area, that is what we call intensity. Energy per second per time interval per unit area. Yeah, see, intensity means what? Energy flux. Brightness, how maximum brightness will get? If you have a maximum number of photons, maximum number of photons will be there, means maximum intensity will come. That's why it is the what is the energy per unit area in a given interval of time is what we call intensity. Energy per unit area, the total energy passing through a given surface area, not unit area, it is surface area. The energy passes through a given surface area in a given time is what we call intensity of emitted photons. Okay, now that is E. So intensity is equal, directly proportional to E by T. E by T is equals to what? Power. Energy by time is per second is power. P by A. Understanding? No. Energy by time is what? Energy means what? Work. Work by time is power. Power you studied first year. Work done is per given time interval per second is what we call power of the instrument. Power means how much work you will do in 1 second. A Texmo motor is there, a water pumping motor. It will work the Texmo motor will work very fast. It will work very fast means it will pump so much water. That means its power is in horsepower, very fast, very high. Understood? So the Texmo motor power is more. Other small motors also there. They will bring they will also take the water. Okay, they will lift the water to some height, but its power may be less because the work done by the machine will be less. Maximum work which machine they will do in a given time, its power will be more. Okay, now intensity is directly proportional to P divided by A. Pressure power per unit area. So it is if you take any spherical surface, if you want to find the intensity of light rays or intensity of light ray at any one point, intensity of light ray at any one point. Okay, for example, the light source is there. This is the light source. Okay, light rays will come. No. Okay, at one point, what is the total intensity of light rays which is moving through this point is which is equal to 1 by 4 pi epsilon naught, okay, P divided by R square into A. This R square you keep, 1 by 4 pi epsilon naught R square P by A, okay. Why 1 by 4 pi epsilon naught will come? You studied so many ways now, this 1 by 4 pi epsilon naught. Hey, sorry, not 1 by 4 pi epsilon naught. Sorry, wait, don't. Epsilon naught, why it will come? It is, intensity is, okay, 1 by 4 pi R square P by A. Okay, so intensity is inversely proportional to 1 by R square. Distance is R, it is 1 by R square. Here A is what? 4 pi R square. Why 4 pi R square? What is A?
Area.
Area of what?
Unit.
Spherical surface. That's what. Here P by A is there, no? So that's what confusing you. 1 minute. You see here? Intensity is equals to power divided by area. Power is what? P. Area of the surface is 4 pi R square. That is what intensity. Now can you please tell, this power is there, no, here, and this area is there. Why this they taken surface area of a sphere? Why surface area of a sphere? Because light is a spherical surface. Light always comes in a spherical form. This is the time it asks this question. Light will come in the form of, you people studied, no, in wave optics. What you studied? Light is spherical. They are spherical size particles. Photons are spherical balls. They are like spherical balls. Okay. Every wave front, every source of light is a new source, right? Huygens says every old source will become a new source, and it will always comes in the form of a sphere. Light will come in the form of a sphere. So the surface area of the sphere, okay, that area only surface area, and this is proportionality we will take sometimes, which is also equal. Okay, please take one problem based on this. First. The momentum of photon of wavelength 5000 angstrom, done, right? Yes. Yes, you take. This is a surface area of a sphere. Surface area of sphere. Calculate the next question. I will write. This one done, right?
Yes, sir.
Write the question. The number of photons, write it. The number of photons, photoelectrons of wavelength 600 nanometer. The number of photoelectrons, the number of photoelectrons of wavelength 600 nanometers emitted by a 30 watt power of bulb. 30 watt power. Okay, 30 watt power means it is 30 watt per second. You can also write 30 watt per second is question mark how much? Do it. So the power they given is solution, I'll write power they given is how much? 30 watt. 30 watt. They are asking wavelength lambda. Sorry, wavelength lambda they are given 600 nanometer. 600 nanometer. They are asking n number of photoelectrons. Simple. Tuck, 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 tuck. You should do. What is the answer? Do it fast. 2 minutes time I'll give. What is the problem? Fast. Till 8:30 we'll do now. What is the answer? If you are not doing fast means, okay, I will also take so much time. Yes, Venu, please try. Jashmita, can you try on the board? Try. Okay. If you do there, no problem. What is the formula for number of photons? What we know? Yeah, correct, right? I said one relation. P is equals to what? N into E. Correct, right? P is equals to NE. Total power is equals to power means total energy per second. Total power is equals to energy of each photon into number of photons. Energy of each photon into number of photons. Now P is equals to NE. So N is equals to P divided by E. Okay. Now P divided by E, right? Yes. 1 minute. They given power, right? Power is 30. One more formula is there. E is equals to h mu. You know, you see. Yes. P is equals P divided by E is equals to h mu. Hc divided by lambda. Okay. Now n equal to P is how much? 30 divided by h into C by lambda. Lambda is how much? 600 into 10 to the power of minus 9 divided by h is 6.625 into 10 to the power of minus 34 into C is 3 into 10 to the power 8. Yes. Do it. Whatever, do. Fine.
What is 30 into 600?
30 into
600.
got the answer? Very slow people. I will do here. N equal to how much? 30 into 600 is there, no? You take it as 30 into 6 into 10 to the power of minus 7. Correct? No. 600 you make it 6 into 10 to the power of minus 7. 600 into 10 to the power of minus 7, 9, you can write 6 into 10 to the power of minus 7 divided by 6.625 into 3 is how much? 19.8 into 10 to the power of minus 26. This minus 20, if it go up, it will become plus 26. Now n is equals to, what is 30 by 19.8? 30 by 20 you do. Approximately take 20. Okay, 30 by 20. 30 by 20, 20 by 19.98 only you do, man. Because exact value we need. 30 into 6 is also there. Yes, 30 into 6 is how much? 180 by 19 point, approximately take 20. 180 by 20 into 10 to the power of minus 19. Oh, sorry, plus 19. Minus 26 if over plus. 0, 0 cancel. Amma, it is 7 minus 26. 9 into 10 to the power of 19. You can make it 10 into approximately. No, it's not possible. Correct, right? 9 into 10 to the power of 19. Okay, that's the answer. That is the number of it. Minus 19. Oh man, minus 26. If you go, it will become plus 26. Plus 26 minus 7 is plus 19. Yeah, next question. So whatever we got is 9 into 10 to the power of 19 we got. Correct, right? Approximately this also we can write like this. See here, 9 into 10 to the power of 19 we got. If 9 is, if you take it as 10, okay, 10 into 10 to the power of 19, for example, then it will become 10 to the power of 20, approximately. Next question. Then take fast. Any doubt is there? Ask me. No? Now, please take a question. Find the question number 2. 2 not 20 na. Here I written 1. Okay, this concept 1, right? You take question number 2. Yes. Find the intensity of photons okay at a point 4 meter from the source of power, how much? 20 watts, 10 watt. You take anything. What is the last problem we got? How much watt you used? Bulb? 30 watt. Okay, use 30 watt only. 30 watt bulb. 30 watt bulb. Okay, this one question. Find the intensity of a photons at a point 4 meter from the source of a power of 30 watt bulb. Okay. If, next one question. If the number of photons is increased by 4 times, then the intensity increases how many times? The intensity increases how many times? How many times? Times and half a time. Please read. Fast we should do. Hare Krishna, Hare Krishna, Krishna. Done, na? Solution. Hmm? Done. Hare done, not done. Say, what is there to think? What is the formula for intensity?
P by 4 pi.
Intensity is equals to P 4 pi r square from the source. Power, how much they given? 30 watt divided by 4 pi. What is the radius? Distance? 4 meter. So 30 divided by 8. Intensity unit is, what is the intensity unit? Luminous intensity unit is what? Candela. Now next question. Then if the number of photons is increased by 4 times, if the number of photons increases by 4 times, then what is the how much intensity will increase? How intensity depends on number of photons? endada prashnama power is equals to n into energy. N is number of photons. So if it is, hey, yeah, r square, right? 4 square is 16. 16 fours are 64. Oh, very nice. See, very unfortunate. Very fortunate. Okay, so what is the, if intensity, if number of photons increases 4 times, then intensity also increases 4 times, because intensity is directly proportional to number of photons. Understood? Okay, so this much is about intensity. Next, done, na? Tomorrow if you not answer questions, no, then it will be there. Next. Yeah, of course. Today is Wednesday. Tomorrow is physics. Tomorrow we'll complete today on all these things. Okay. Tomorrow new chapter. Which chapter you want? Ray optics. Yes, who is that new people? Okay, please take next. Einstein's photoelectric equation. What is Einstein's photoelectric equation? Einstein's Einstein is a scientist. Is correct, Einstein spelling?
No, sir, no.
Why?
First should become I. No, sir, his name starts from I. No, his name starts from I.
Huh?
His name starts from
Ayya, what this guy? Einstein's photoelectric equation. Don't worry. Photoelectric equation. These spellings and all sometimes the English is. Okay, what is the Einstein's photoelectric equation? H mu is equal to H mu naught plus half mv square. Very good, very good, very good. H mu is incident energy. H mu naught is work function plus kinetic energy. Correct, right? Just take the question. Question number 1. Question number 1 I will just read out. Please listen. Yeah. The threshold frequency of a metal is the threshold frequency of a metal is the threshold frequency of a metal is F naught. Okay, threshold frequency of a metal is F naught. When the light of frequency 4F naught is incident on the metal, when the light of intensity 4F naught, when the light of intensity 4F naught is incident on the metal, surface then what is the maximum kinetic energy of emitted photoelectrons? Find kinetic energy. Find Ke maxima. Max. Do it. This is a simple question. Please do it. It's very easy. How much is the answer? You see, listen here. H mu is equals to H mu naught plus half mv square. Correct, right? Now you see this equation I will write here. H mu, H, what is the incident frequency? What is the incident frequency? Hey, here it is not intensity, yeah? Frequency. Frequency. 4F naught. Correct, right? 4F naught is equals to H mu naught. Mu naught is how much? Threshold frequency is how much? F naught. F naught plus half mv square. Now what is half mv square? Tell from this. I will write here, okay? Half mv square is equals to 4hf naught minus hf naught. How much? 3h. Done na? Easy no? Incident frequency 4f naught. Threshold frequency f naught.
So in that shall we put as difference?
Next question.
this video.
If you want, I'll give. Take the next question. Done now. Yes, next question. Find the yes, sorry, yeah. Next, question number 2. Find the maximum velocity of photoelectrons. Maximum velocity of photoelectrons find the maximum energy of photoelectrons when find the maximum energy of the velocity of photoelectrons when a potential of hmm, a potential of 2 volt, not 2, 20 volt is applied to the collector plate. Here given is mu is 20 hertz. Otherwise energy only I will give. Okay, energy, is it fine? Mu is fine. Work function is okay. Mu is 30 hertz and mu naught is 10 hertz. Is it? Right. Very, very simple question. Find yes, what is the answer? What is the relation between stopping potential and kinetic frequency? Now you see, kinetic energy half mv square is equals to, you studied, half mv square is equals to what? Stopping potential ev naught. Half mv square is equals to ev naught. Okay, now ev naught is equals to, what is half mv square? H mu minus mu naught. Okay, what they are asking actually? Velocity, maximum velocity. First you find this ev naught. Oh, no need to find only, no need to give 20 volt, they already given. Correct, right? Everything they given. No need to find, easy to find. Directly you can write. V is equals to what? Velocity V square is equals to 2e V naught divided by m. So V is equals to under root 2e V naught divided by mass of electron. You should know mass of electron. Then you can apply this. Otherwise, there is one more formula. Sir, it is difficult, sir. I want another formula. mv square half mv square is equals to h mu minus mu naught. Now v square is equals to 2h mu minus mu naught divided by m, and v is equals to under root 2h mu minus mu naught divided by m. Huh? 20.
That is potential.
Which one? This is potential. You can apply directly here also using this potential. This is also one formula. This is the second formula. Both you can apply. Both say give same answer. If you want, you check. Okay. Do it. What is the answer written? Take this question. V is equal to 2 into under root 2, h is 6.625. 2 into 6.625 into 10 to the power of minus 34 into frequency difference is how much? 30 minus 10 is 20 divided by mass of electron is how much? How much? What is the mass of electron, Gundo? What is mass of proton?
6 into
Mass of electron is, I think 6.6 is charge. 9.1 into 10 to the power of minus 31 kg. You should multiply this, you'll get the answer. Do it. Find the answer. Thank you. Yes.